When I was younger, I was quite fascinated by magic tricks, as there is always something invisible to the spectator's eyes. So what does this have to do with physics? Let me show you. Here we have two magnets. If we put two of the same poles together, they will repel. However, if we put two of the opposite poles, they will attract. So this idea suggests that we have a magnetic field acting around the magnet. But this idea has its limitations. Take two bar magnets. Let's say that this is the North Pole. If we bring those two magnets together and we see them repel, then we know that this is also a North Pole. Now, let's add an unmagnetized piece of steel to this North Pole that will become a part of the North Pole. This time, if we bring them together and release, they don't repel, they attract. So what's going on here is that both of the magnets are trying to pull this piece of steel apart. Now, if we give them the opportunity to do so, they will indeed repel. Another situation where we see odd behavior by a magnet is when we take a steel plate, an unmagnetized steel ball, and we take the steel ball and put it up against a magnet. We take the steel plate and touch the steel ball. Every time we're able to bring away the steel ball. The results that we just saw from the previous two examples, it's very difficult to explain with the idea of poles. And if something is difficult to understand, what physicists do is that they build an analogy. And for our analogy, we will build a magnetic circuit. And our magnetic circuit is going to consist of an iron core. On one side, we're going to put a coil of 300 turns. On the other side, we're going to put a coil of 72 turns, and this is connected to a little lamp. And we're going to complete the circuit. Now, if we turn on the AC power supply, we see the light turns on. That means there must be something moving inside the iron core. And we call that something magnetic flux. We can disconnect the circuit and turn on the power supply. We still see the light up. It means air is conductor of magnetism, even if it's a bad one. To demonstrate further, I have drawn out a wire as the magnetic field lines would appear around a bar magnet. But instead of a bar magnet, we're going to use a cell. And as air is a bad conductor of magnetic flux, these here are high resistance wires. Here we have an ammeter that will show the current flow through the wires. We're taking a copper plate as it's a good conductor of electricity. That would be represented by the steel block, which was a good conductor of magnetism. As we put the copper plate onto our wires, the current reading will increase as the more wires it will touch. So we have gone from 2.4 to 2.5 to 2.6 and increasing. This describes a law of nature where it always tries to reduce the reluctance of the external circuit. And this is the idea that can explain our previously shown experiments. I've just shown you one way the leading physicists are disassembling the wonders of the world to explain them in their own words. Do you now see how this ties in with magic? I propose the world is our magician and we are the spectators trying to unravel the literally invisible secrets we are confronted with. But hopefully, there's a way to explain them.